Problem 1, I'm just assessing your ability to go from scientific notation to standard and from standard to scientific notation. So I'm going to move 4 places to the right because it's positive. 1, 2, 3, 4, 9, 3, 5, 0, 0. Okay, I'm going to move 5 places to the left because it's negative. 1, 2, 3, 4, 5, filling in each of those 4 places with zeros. Now I have standard form. Where is the decimal? It is hiding in back. And I'm going to move it all the way to the left to only one non-zero number is in front. 1, 2, 3, 4, 5, 6, 7. And it's not necessary if these are all zeros to put them on. I would not count it wrong if you do have them. All right, so there are 6 zeros here. How many times do I have to move it till I have one non-zero number in front? 1, 2, 3, 4, 5, 6, 7. 7 times. Now this original number here was greater than 1. That's why it's positive. This original number is less than 1. That's why it's negative. Whenever you find the y-intercept, we are going to plug 0 in for x. So negative 2/3 times 0 is 0. 0 minus 6 is negative 6. In this form, y equals mx plus b, the number, the constant, that's all by itself with no x is the constant. Is the y-intercept. Let's move down here. How do you identify the x-intercept algebraically? I'm going to plug in opposite of the variable. So you're not plugging in 0 for x, you're plugging in 0 in for y. I'm plugging in 0 in for y. You're welcome to write all over your paper if you have this wrong, because I would need to see work for an upcoming test. Now, how do you isolate the x? I'm going to first move 6 to the opposite side by adding. 0 plus 6 is 6. How do you remove a negative 2/3 so that x is isolated? I'm going to multiply by the reciprocal, which is negative 3/2, negative 3/2. So the 2's and the 3's in your mind, you may say cancel. Realistically, they are going to simplify to 1, and you're only left with x. On the left-hand side, negative 3 times 6 is negative 18. 2 times 1 is 2, and this reduces down to negative 9. Without using a calculator, I'm provided with 4 data points from a particular linear line. We want to write the equation of the line. So I only need 2 points to write the equation of a linear line. And so when I look here, I don't want to work with decimals. I'm going to cross those out. I'm going to say negative 10, negative 1 is the first ordered pair. So it's x sub 1 and y sub 1. And negative 5, 1 is the second ordered pair. So it's x sub 2 and y sub 2. I'm going to write this linear line in the form y equals mx plus b. M is the slope. So the equation for the slope is going to be y sub 2 minus y sub 1 divided by x sub 2 subtract x sub 1. That is the equation you have to have memorized. Now I'm going to put in the variables. So y sub 2 is 1, y sub 1 is negative 1, x sub 2 is negative 5, x sub 1 is negative 10. This is all done without a calculator. Bless you, 2 negatives make a positive. 1 plus 1 is 2. Now negative 5 subtract negative 10. 2 negatives make a positive, and negative 5 and positive 10 is positive 5. This is the slope. There's 2 things I need to know in order to write the equation of this line that contains these points. One is the slope, the second is the y-intercept. So y equals, the slope is 2/5, and the last thing is I choose any one of these points. There's no wrong answer. I'm going to choose this one. It looks the simplest to work with. This is the x, this is the y, and I'm going to substitute them in accordingly to solve for b. Negative 5 is the x, 1 is the y, and now to solve for b, I'm going to start by multiplying here. 2 times negative 5 is negative 10, 5 times 1 is 5. This reduces to negative 2.
Happy Tuesday,
I'm going to add 2 to the opposite side, and I get b equals 3.
Classes, including advisory.
Y equals
make sure that you're
2/5
the advisory
x
videos for
plus 3.
We do appreciate
Please flip to the
that.
front. So on this quiz, we have gone through how do you do things algebraically. Now we're going to use the calculator to identify the x and the y-intercept. So I'm going to start by, I've cleared the calculator, and you can plug this in with me. Anytime I plug in a fraction, it's going to go in parentheses. I've made a few mistakes here. I want to slow it down, make sure I've typed it in correctly, and I'm going to graph it. Looks like I've done something wrong. Let's try this again. 1/2 x plus 7/2. That matches up. Let's try now. The first time I hit trace, I'm going to see what the y-intercept is. So whether you'd write down 3.0 and 3.5 or 0 and 7/2 if you prefer a fraction that is equivalent to 3.5, that's okay. How do you identify the x-intercept? We want to be precise. Second, trace 0. I want to go somewhere to the left of what it looks like to be -7. I'm going to try -8. And somewhere to the right, I'll try -5. Now we can see this x-intercept is in between those temporary vertical lines. I press enter one more time, and I do have an exact x-intercept of -7. Please flip over. Right on the back side, number 4, I'm going to type this in. Remember, this is a negative and this is subtraction. So -x squared, subtract 5x plus 7. I'm graphing it. The very first time I hit trace, I will see I have a y-intercept of 0.7. We are going to round to the nearest hundredth for any of the x-intercepts. And so I can see it does not look like it's precisely an integer value. So second trace 0, I'm going to go somewhere to the left of this. So let's try -8. Now somewhere to the right, let's try -4. And now when I press enter, I get a value of -6.14 rounded to the nearest hundredth. Okay, let's come over here. Again, second trace 0. Anywhere to the left of this point. So it could be -1, it could be 0. Anywhere to the right, let's try 5. I press enter, and now we have 1.14 when rounded to the nearest hundredth. Let's go on to our last one that we'll cover in this video, and that is how can you find the solution to the system using a calculator? And what does that mean? That means if there exists one unique value for x, that when I plug in the input for x, I get the exact output for y for both equations. So before I go ahead and I plug this in and I clear things, I recognize that I need to put it in the form y equals mx plus b. That's already taken care of here. But in the second equation, to put it into this form, I need to move this 4 to the opposite side. And I can do that by adding. So I'm going to plug in these two equations at this time. 3/5 x subtract 2/5 and -3x plus 4. I'm going to graph it. And I want to know precisely where do they cross. How do I do that? Well, it's another app on the calculator. So we're going to go second, trace, and go down to number 5, which is the maximum. Second, trace, and all the way down to number 5. And now, because we only have 2 lines, we're able to hit the enter key, the bottom right-hand corner, 3 times. 1, 2, 3. Rounded it to the nearest hundredth, we have 1.2, and I'd be okay with 2 repeating, but rounded to the nearest hundredth is 1.22 and 0.33. This is the exact point, so only one unique point exists that will work for an input and output value for both the top and the bottom equation.